Hello, welcome back in College Algebra. Today we have a new lesson in the logarithm and exponential functions. We're going to know how to solve equations using the logarithm and exponential functions. We're going to start having two rules today, and we're going to use these rules in addition to the rules, the 7 rules that we have learned before in solving the exponential and logarithm equations. So let's start about defining the first rule. I said that let b and x be real numbers with b cannot be greater than 0 and b cannot be 1, then if b to the x equal b to y, actually it must be y here too, that implies that x equal y. What does it mean? If I have equations that the base are the same, therefore the exponents are the same. For example, if I have 2x equals 2 cubed, they have the same base, that means that the exponents are the same, therefore x equal 3. Does it make sense? Okay, so let's get an example to explain that. So, if I go to an example here, I have example 1, 2 to 3x minus 1 equals 32. Okay, so here's the equation, and in order to apply this rule, I must have the same base. But I can put 32 in base 2. How can I do that? So basically, 32 is 2 times 2 times 2 5 times. So it is 2 to the 5th. So I can write this as 2 to 3x minus 1 is 2 to the 5th. Now I have the same base, therefore the exponents are the same. So 3x minus 1, that means this 3x minus 1 equal 5. And now it's a linear equation, and it's easy to solve this linear equation. I add 1 to both sides and then divide by 3. So 3x, add 1, so 5 plus 1 is 6, and divided by 2, divide by 3, so x equal 2. Okay? One more example. So the idea here in this kind of problems is to make sure that the bases are the same, and then we can say that the exponents are the same as well. Okay, one more example. 16 to 1 minus 2t equal 1/4 2t. All right, so here's nothing of them are the same, so 1/4 and 16. But I know that we can rewrite both of these in terms of base 4. So 16, basically 16 is 4 squared. And 1/4 is the reciprocal of 4. So that means it's 4 to negative 1. So now I converted both of these to base 4. So I'm going to rewrite 16 as 4 squared to 1 minus 2t. Okay? Equal 4 to negative 1, so 4 to negative 1 times t is negative t. Okay? Now I'm going to get this 2 out because I distribute the power, so I'm going to get the 2 out. So this is 4 to to 2 times 1 minus 2t equal 4 to negative t. Now, I can apply the rule. I have b to the x equals b to y, then x is y. 4 to 2 times 1 minus 2t equals 4 to negative t. Therefore, I can say that 2 to 1 minus 2t equals negative t. Now again, I have a linear equation and I easily evaluate t. So we distribute the 2. So 2 times 1 is 2, minus 4t equals negative t. I can add 4t for both sides. So I have here 2, and 4t minus t is 3t. Divide by 3, so I have t equal 2/3. And this is the answer. Again, make sure that you have the same base, okay, and then you can apply this rule. All right, what if I have two numbers that are relatively prime? These numbers are not relatively prime because they have a common base. But what if I have two numbers that they don't have the common base? So let's see an example like that. So example 3 here, 5 to x equals 12. So 5 and 12 are relatively prime. I can't have a common base between both of them. So what I'm supposed to do here? So here I'm going to go to rule number 2. This is rule number 1. And rule number 2 is log x, if log x equal log y, then x equal y. Okay, so this is the exponent, this is the exponential equation, and this is the log equation. So I want to say there's 1 if, there's 2 if. So if log x equals log y, then x equal y. Also, if x equal y, then log x equal log y. You can apply this on log and also on the natural log. It's the same thing. I'm going to use natural log here. But you can use log. It's the same. You choose wisely log or natural log based on the base that you're given here. For example, if you're given the base 10 here, it's better to use log. But if you're given base e, then it's better to get a natural log. So I'm going to go for natural log because there is no base 10 here. So natural log, I'll take the natural log for both sides. 5 to x equals the natural log of 12. Is that clear so far? X equal y implies that log x equals log y. Or natural log x equal natural log y. Okay, now I can solve for x. But I know that there is a rule we have learned before, is the power rule. So I'm going to remove the x. I move x in the front of the log. So I have x natural log of 5 equals the natural log of 12. Now I want to isolate x. I'm going to solve for x. So x, I divide by the natural log of 5, natural log of 5. So I get x equal, this is going to be 1, equals natural log of 12 over the natural log of 5. And now I get the solution for this one. Okay, let's get another example. In this example, I'm going to use the rule that we learned before, that is the log b to the x equal x. So we're going to highlight this rule to know that rule. Okay, so we're gonna look how to solve this one. So I have here 5 e to 2x minus 1 minus 9 equals 30. So here's the point here. I can solve this. I need to isolate here the guy. So in order to do that, I'll do 2 steps. Number 1, I'll add 9 to get rid of the negative 9 and then divide by 5. So let's do the first step. 5 e to 2x minus 1 equal, add 9 to both sides, so I have 39. And then I divide by 5, divide by 5, divide by 5. So I have e to 2x minus 1 equals 39 over 5. So why did I do that? Because basically I want to use the power rule. But you can't use the power rule in this case. So you need to isolate this one. Okay, so now I can use the power rule, but in order to use the power rule, I have to use the natural log. Okay, here's the thing. Would I use natural log of log? And why? Okay, if I use the log has base 10. The natural log has base e. So which one do you think? Should I use log or natural log? Basically natural log, because I have an e. And that would be very impressive. And we'll see why is it impressive. Okay, so take the natural log of both sides, e to 2x minus 1 equals the natural log of 39 over 5. Okay, so far? Now, use the power rule. Now I can use the power rule. I have 2x minus 1, so the natural log of e equals the same 39 over 5. Basically, without going to this step, what is the base here? Yes, e. So let's go to this rule. Log b to the x is x. So that means that the answer here is 2x minus 1. Okay? So I have here 2x minus 1 because of the natural log of e is always 1. Okay? Equal the natural log of 39 over 5. Over 5. Alright. Now, this is a linear equation. We consider natural log of 39 over 5 just a number, so it's not a problem. So I add 1 to both sides, so I have 2x equal, and watch this, natural log of 39 over 5. You see why I put it in a parentheses? Because I can't add 1 to the argument. The argument is different, so I can't add the 1 to the 39 over 5. This argument is the domain or the value of the function natural log. But this is a kind of shifting the function. So this one and the 39 over 5 is totally different. It's similar like f of 5 plus 1. This is not equal to f of 6, right? So because this is the argument, so we can't add them together, right? I hope that this is clear. Alright, so now the last step, I want to isolate x. So I will divide by 2, so x equal all of these 39 over 5 plus 1 divided by 2. Okay, let's get one more example. using the same idea of that rule. Yeah, it needs that you work some steps here, right? Yeah. Sometimes I see that these kind of problems are confusing. Like, which rule should I use here? Why this rule doesn't work? I got stuck. But you need to practice. Keep practicing these stuffs, and it's gonna be doable. So I'm gonna give you a lot of homework for these problems, so that will gonna be helpful for you. All right. So let's get this problem. I have 10, 8x minus 3 plus 45, 0 equals 24, 0, 0, 0. I don't think that this marker works. This one. Too much writing. Alright, so what should I do here? Again, I need to isolate the base. I need to isolate that guy. Let's write it down here. I want to isolate this. This is similar to what I did here. So how can I do that? It's just one step. Get rid of the 4500. So all I need to do is to subtract the 4500. So 10, 8x minus 3 equals, so 24,000 minus 4,500 is 19,500. Correct? Now, I have a question for you. Which one should I use? The natural log or log? Look at the base. Is the base e or 10? Oh, the base is 10. So again, keep in mind that way. If the base 10, use log. If the base e, use natural log. If it is any other base, use whatever you want, natural log or log. Is that clear? Okay, so here, because they have base 10, and that helps me, 10 and 10 are going to be cancelled out, so I will be having that based on that rule. So I'm going to use the log. So log 10 to 8x minus 3 equals log 19,500. But now this is 10, so log b to the x equal 8x minus 3. So that I have here 8x minus 3. If you don't believe me, use the power rule, get the 8x minus 3 here, and then log 10 to 10 is the same like log b to b, which is 1. Okay? So this is equal log 19,500. Now let's solve for x. So I add the 3 to both sides. I isolate 8x first. So I have log, watch here. I'm going to put this in a parenthesis because again, this is the argument. I can't add the 3 to the 19,500. So log 19,500 and then plus 3. Then the last step is to divide by 8. I divide by 8, divide by 8. So now I have x is that guy. Okay, I hope that this is clear. I have 3 more problems. Alright, let's get maybe it's the same rule, but I'm not going to do this, so let's see. So I have, also I'm solving for x, 7, 3x minus 1 equals 4, 2x plus 5. Okay, again, these bases are relatively prime. I can't find a common base between them. So I'm going to take the natural log or the log. I like the natural log. The natural log, 7, of 3x minus 1 equals the natural log of 4 of 2x minus 5. Okay? All right. Now I'm gonna use the power rule. I'm gonna use the power rule here. I get all of these here and all of that here. Let's make this as parentheses so you know that I'm going to move the whole power. Okay, so 3x minus 1 natural log of 7 equal 2x plus 5 times the natural log of 4. Now, here's a problem. With these problems, I had x on one side and it's done. But now, I have a tricky thing. I have x on both sides. So what am I supposed to do? So let's see the idea here. So here, you know that natural log of 7 is just a number. Think about that natural log of 7, let's say 2. So you can distribute 2 to multiply 2 by 3x minus 1, and here, let's say 3 or 4 by multiply, then they distribute the natural log of 4 and distribute the natural log of 7. Okay? If you think that the natural log of 7 and the natural log of 4 is just a number, you can do so. Okay, so I'm going to multiply the natural log of 7 times 3x. So I'm going to call this 3 the natural log of 7, okay, times x. Okay, so this times x. All right, and then minus 1 times the natural log of 7. Okay, and I'm gonna put natural log of 7 in parentheses equal. I'm gonna multiply natural log of 4 times 2x. So it would be 2 natural log of 4, okay, times x. And again, you can't multiply x by 4, okay, plus 5 natural log of 4. So far so good? Now, the next step is to combine the x's together. So I'm going to move this x here and the natural log of 7 there. So the 3 natural log of 7 times x, and here is minus 2 natural log of 4 times x. Then I'm going to add the natural log of 7 to the other side. I'm going to move that, so I have the natural log of 7 plus 5 natural log of 4. If you have a question, please email me about that. I'm trying to be faster here because I know that you know how to move stuff from negative to positive from side to another. Now, I have this multiplied by x and this multiplied by x. The good way here, I'm solving for x, so I'm going to factor x. So I'll take x as a common factor here. So when I take x as a common factor, I have 3 natural log of 7 left, minus 2 natural log of 4 equal natural log of 7 plus 5 natural log of 4. Now, I need to isolate x. So we're going to divide by whole thing here. So I'm going to divide by 3 natural log of 7 minus 2 natural log of 4. And again here, 3 of natural log of 7 minus 2 natural log of 4. Now I have x, because I'm dividing by the same thing, so that would be cancelled out. This is 1. So I have x is the natural log of 7 plus 5, the natural log of 4, divided by 3 natural log of 7 minus 2 natural log of 4. Okay? It's a long problem, but I'm pretty sure you can do it. Just focus on the steps and it would be done. So let's think about the steps. I want you to understand it. So the first step, check the bases. The bases are relatively prime. So take either a natural log or the logarithm. It depends on if you have 10 base 10, then use a log. e, use a natural log, else use either, whichever you'd like. Then use a power rule, and then distribute. So we multiply here, get the x on one side, okay, and then factor x, and then isolate x and solve for x, okay? All right, let's get one more example, maybe two. I like giving you more examples, so it would be better when you see the idea more than once. Okay, I have 2x e to x minus 6 e to x equals 0. Wow, that is a new problem. So what I'm supposed to do here? What I'm solving for? X. So I'm solving for x. So if you think of a common factor here, I have x and x. So this is complicated, but think about e to the x. Can I factor e to the x? Yes. Suppose that e to the x is y. Yes, I can factor e to the x. I'm going to take e to the x as a common factor. So what's left here? 2x. And what is left here? 6. This is equal 0. If you think about this, this is a zero product rule. If you remember that, so either e to the x is 0 or 2x minus 6 is 0. I'll start with solving this first. So 2x minus 6 is 0, that means that 2x equals 6, divided by 2x is 3. And this is sweet. This one. There is no solution here. You can't have a value of x that makes e to the x is 0. So if you think about this, this is e to the x. This is e to the x. Never touch the y0 here. Never. So there is no such a value of x, so this is e to the x. There is no such a value that makes y0, because the horizontal asymptote is y0. Okay? So there is no solution. So my only solution is x equals 3.